So hello guys, welcome to the next video of the series Content Factory Agent using langgraph and local models. In the last video we walked through the code and it has changed so much from the last video. Don't worry, I'll cover everything up and let's get started. Before diving into the actual code, I will show you the main workflow of the code that I've made until now. Seeing for the main graph first. Now, before moving further, let me tell you that I've made the entire project with langgraph. And if you are familiar with the langgraph, we create a state, and the state travels through the entire graph via nodes and edges. So, if you are familiar with that, you will have no problem understanding the workflow. So, for the main graph, I've created the state with ID, user prompt, duration. User prompt is a prompt given by the user for the reel or the UGC content. Duration is a targeted duration for the reel. For example, I'm working with 45 seconds right now, and the other fields of the state will be populated by the agent when it travels through the graph. So we take the state, we invoke the graph. The first node the state travels to is the generate script. So here for this node, the I'm using an agent to generate a script, and I give it a very long system prompt. Let me show you the prompt here. For the prompting, I'm using the YAML configuration style formatting. In YAML, it's kind of like JSON. You write configuration style prompts like I'm defining a role, objective, and other guidance, writing guidelines, constraints, do's and don'ts, inputs and outputs, etc. So it saves the context window and it's very efficient on the token economy. So moving further with the code, let me show you this is the first node. It reads the system prompts, invokes the agent, and let me tell you, for the LLM service, I'm also using a local model, which is Granite 4.18 billion parameter, but today I've switched to Quen 3.8 following its latest release. I'll be changing this configuration soon. And here you can see that I have wrapped the LLM integration into a class service. The invoke method simply just invokes with the input. The structured invoke, which is required in the later stages, invokes the model with a structured output, and it is very helpful for the debugging and other outputs. Now, as you can see that I've also defined a free method here, and the purpose of this method is to take the model out of the memory. The reason for that is when the graph reaches the media generation stage, it needs the model that is used for the overall agent orchestration needs to leave the memory, because media generation models are quite heavy, and for my device, which is Apple M4 16 GB unified memory, it is too much. I cannot have all of these models in the memory at once. So for the media generation models to get started, I have to free the LLM model, and its implementation is very simple. I just invoke the model with an empty prompt and a parameter keep alive with the value 0. This parameter helps to free the model out of the memory immediately, so that other models can consume the required memory. So we discussed about the generate script node, and after that, when the script is generated, the model again reads the script and divided it into the clips, which is the next stage of the main graph. Here it's actually the same, and for the clips I have created two more pydantic classes which will help with the structured output. So I have defined my clip into a short class, which will give me a short index, a description, a generation prompt which will be used by the media generation model, and a duration seconds, which is optional because I'm constrained on the memory. So I'm for the video generation models, it will be 4 to 5 seconds. and a short list, which is just a list of the above class. For this also I'm using a system prompt, which is clips.txt. As you can see, I'm using the same YAML configuration for the prompts. I define a role, I define the process, a short division guidance, image prompt guidelines, constraint, and inputs. Before using this prompt, there was too much inconsistency between the outputs of the shots. So to maintain the consistency among the shots, it is very important to concisely define it in the prompts to keep the background, keep the protagonist, and other things in relevance among the clips, so that all overall media stays consistent. So in the generate clips, we create entire script into the shots, and after this the shot is updated into the clips state of the graph. So after generating the clips, we move to the next node, and in the next node we invoke our subgraph, which is the image generation graph. So here is the image generation subgraph. I've combined the image and video subgraph into one because they are eventually the same. So starting with the image state, in the state I include an ID which is given by the previous node, a prompt which is also taken from the short, a prompt ID which is generated by Comfy UI, and these other state fields will be updated when moving through the graph. So we invoke the subgraph with our image state, and after invoking, the first node we encounter is the submit job. So the role of the submit job is to actually send the workflow to the Comfy UI backend. So here I've added some debugging states, and I've also generated a seed. A seed is necessary for the image generation, and this seed will be used by the Comfy UI backend to get good results for the generation. So here I queue the generate image with the prompt and the seed. In the main graph, I have invoked this in the dispatch jobs node. As you can see, for each clips, I am invoking the compiled image graph and adding my prompt in the topic field, and ID I'm creating that by myself. And one thing you will also see that I'm executing this task using asyncio.gather method. In the Comfy UI backend, the images will be generated one by one, but the overall process of polling and deciding whether to save the asset or not, this process will be executing concurrently in this application. Overall, the Comfy UI backend will perform linearly because the batch size is 1. But in this application, the task of polling and another graph task will be executing in concurrence. This is necessary because if I didn't use this, what would happen is that the graph will just poll only one job before moving to the next, and that would increase the time of the execution. So here this is the last node of the main graph. So in the image graph, we submit the jobs, we get into the polling job, we then poll the jobs, all of them, and in our polling job I have added a conditional edge, whether move to the save asset or whether move to the waiting node, and in the waiting node we sleep the graph for 30 seconds. So in the polling job, we poll the Comfy UI backend and it sends the status. If the status is completed, we update the state with the completed, and if it's still running, we update the status with running. And this is our should continue polling state edge, which will return on which node we should move on to. Sorry. So in the waiting node, I'm using asyncio.sleep, and it is different from the previous time.sleep. In time.sleep, it is a blocking operation, and it will completely freeze the application for 30 seconds, but in async.sleep it will say the event loop that come back later in 30 seconds, and it can still execute other tasks that are in the event loop. So that's the main difference here now. And here I am adding that conditional edge using the function and both of the results. So this is the image graph. Now moving back to our main graph, as you can see I've added another node, generate narration or audios, and the next node is assemble, stitch, edit and aggregate. So these two nodes I have not yet implemented in this main graph, and but I do have a final result. This is Palmier Pro video editor, and this is an AI powered video editor. I basically used Claude to edit my videos with this video editor. As you can see, I have added my 4 of the generated images, the audio, and the audio script that I've generated using Omni Voice. Here, this was the script. Uh, Currently, I'm using a hard-coded implementation. Later, I'll automate this process also in the main graph. But for creating a first result, I've used the hard-coded values. In Claude, I just prompt the Claude to do the following operations, like adding the images, breaking down the audio tracks, adding subtitles, adding transitions, etc. And to show you the final result, you can actually see that here.
At dawn's first light, a sleek stray prowls the fish market stalls, whiskers twitching at the scent of fresh seafood. Quick paws dart between legs, snatching morsels tossed by grateful vendors. As morning turns to midday, the cat weaves through crowded streets, dodging oblivious pedestrians and savoring the urban rhythm. By late afternoon, weary but content, it climbs a weathered fire escape, pausing atop a sun-kissed rooftop where the city's hum fades into a gentle lull. There, curled tight against the warm stone, twilight embraces its day of silent triumphs.
Well, as you can see, it's not the best result, and also it is less than the target duration. So these are some of the fixes that I'll make in the next version, and I'll also keep you updated for this. So this is the devlog for now. Thank you. If you're watching this video, kindly consider to like and subscribe, and I'll try to add more videos more frequently for this project. So thank you so much.